We have ignition. We have a liftoff embarking on a journey into space usually reserved for spacecraft. NASA's Voyager 1 has been an exceptionally reliable explorer, delving deep into the cosmos. Voyager 1 is catching the attention of scientists by transmitting peculiar signals from its current location, an astounding 23 billion kilometers away. Despite its vast distance, Voyager 1 continues to send mysterious signals back to Earth. Is there a glitch in Voyager 1's system, or is it faithfully executing its mission by sending crucial warning signals? The most distant human-made object, NASA's Voyager 1 spacecraft, is an interstellar space explorer. Join us as we uncover what happened just 3 minutes ago when Voyager 1 turned back and made a startling discovery. Reflecting on the incredible achievements of modern humans, who have surpassed the wildest imaginations of our ancestors, consider that for millennia, billions of humans gazed at the moon, never imagining the possibility of setting foot on it. However, through incredible inventions resulting from the tireless efforts of brilliant scientists and engineers, such achievements are now within our grasp. Organizations like SpaceX and NASA are pushing boundaries, targeting missions to Mars, and propelling us further into space. While the objectives of these missions may vary, landing on Mars represents a pivotal moment that will significantly expand our reach into deep space. Nevertheless, there are inherent limitations to what human space travelers can accomplish. As the vastness of the universe beckons us to explore numerous phenomena, many of these endeavors would take us billions of miles away from our only comfortable abode, Earth. This is where space probes come into play, serving as our eyes in places beyond our technological reach. Voyager 1, launched 4.5 decades ago, stands as a timeless observer in the vastness of space. Alongside its counterpart, Voyager 2, the Voyager missions serve as historical capsules, encapsulating the essence of their era and captivating the public's imagination. When evaluating humanity's most extraordinary triumphs, the Voyager missions require acknowledgement, offering unparalleled scientific returns. Voyager 1, in particular, proudly holds the title of the first spacecraft to leave the solar system and venture into interstellar space. Launched in September 1977, Voyager 1 roams more than 146 billion miles, 235 billion kilometers, away from Earth, solidifying its position as the most distant spacecraft from our home planet. Its trajectory symbolizes the apex of human innovation and exploration, underscoring our capacity to extend our influence beyond the boundaries of our solar system. NASA's Jet Propulsion Laboratory reported that the spacecraft is steadily propelling itself away from us at an impressive speed. Voyager 1 is currently soaring through space at an impressive speed of 38,000 miles per hour, 61,000 kilometers per hour. Notably, the significance of Voyager 1 endures even 45 years after embarking on its mission to explore the outer planets of our solar system. This probe has exceeded all expectations, continuously transmitting data about its journeys back to Earth. A landmark achievement for the spacecraft occurred when it entered interstellar space in August 2012, marking almost 35 years into its journey. However, this groundbreaking discovery was not revealed until 2013, allowing scientists sufficient time to thoroughly analyze the data returned by Voyager 1. Serving as the second of the twin spacecraft to be launched, Voyager 1 was the first to race between Jupiter and Saturn. For a generation, the images sent back by Voyager 1 have become integral in school textbooks and numerous media outlets. Notably, the spacecraft carries a unique artifact known as the Golden Record. It was designed to convey voices and music from Earth into space, with the hopeful notion that sentient extraterrestrial beings might detect and take interest. These discs' images were compiled by a committee led by astronomer Carl Sagan and stored in gold-plated copper discs engraved in the style of a vinyl record album. A segment of the disc contains audio information, including music, greetings in 55 different languages, some obscure or extinct, and nature sounds. In addition, the discs feature 122 images encoded as vibrations on the disc, accompanied by decoding instructions. Symbols on the cover plate of each disc illustrate the method of playing back the record, and image decoding instructions reveal details such as the image start signal, image aspect ratio, and reproduction of the first image, allowing potential extraterrestrial recipients to verify accuracy. Completing the ensemble is a star map depicting Earth's location in the vast cosmic expanse. If the discs are ever played, extraterrestrial listeners would be treated to diverse traditional music from various cultures, including Native American chants, Scottish bagpipes, and African ritual music. The compilation also features a greatest hits collection of classical music, with more contemporary additions being Chuck Berry's Johnny B. Good, and a jazz number by Louis Armstrong. Although the world has evolved since the 1970s, now embracing genres like rap and reality TV, it's heartening to have a representation of our cultural heritage so far out in space. In a clever move by NASA, the Voyager mission included a way for potential alien discoverers to learn how long the probe has been in space. If these beings are intelligent enough and familiar with half-life, they can examine the uranium-238 fragment attached to the main bus near the record for isotope ratios. Interestingly, some express concerns that any hostile alien stumbling upon the Voyager disk might find a map leading them directly to Earth. While the notion of the Voyager transmitting signals from interstellar space may seem alarming, the journey is far from urgent. These spacecraft will spend tens of thousands of years in the vastness of interstellar space before reaching another star. Their situation, although enduring, is not urgent, and if the disks they carry are ever discovered, it might be in a distant future where humans may no longer exist. An intriguing aspect of the Voyagers is their remarkable endurance. Even after ceasing to work or transmit, they will outlast us. The absence of atmosphere in space eliminates the risk of corrosion, and in interstellar space, there is little for them to collide with. One of the most noteworthy accomplishments of Voyager 1 was the Grand Tour, made possible by an unusual feature. The Voyager missions capitalized on a rare alignment of the outer planets that occurs once every 176 years. This celestial alignment provided a strategic opportunity for the spacecraft to employ slingshot maneuvers, navigating seamlessly from one planet to the next while maximizing their use of limited fuel. Initially, NASA envisioned an ambitious initiative involving 2 probes charting paths past Jupiter, Saturn, and Pluto, with an additional pair venturing past Jupiter, Uranus, and Neptune. Regrettably, budgetary limitations compelled NASA to scale down these ambitious plans. Despite these limitations, the 2 Voyager spacecraft achieved significant milestones. Voyager 2 completed flybys of Jupiter, Saturn, Uranus, and Neptune, while Voyager 1, staying close to Jupiter and Saturn, almost faced a significant setback during its launch. Its rockets came within 35 seconds of running out of fuel. However, the probe successfully entered space and swiftly outpaced its twin, passing through the main asteroid belt between Mars and Jupiter before Voyager 2. Voyager 1 achieved remarkable milestones by delivering Earth its initial glimpses of Jupiter in April 1978, capturing global excitement from a distance of 165 million miles, 266 million kilometers. The revelation triggered celebrations worldwide. Subsequently, in March 1979, Voyager 1 made a startling breakthrough by uncovering a delicate ring encircling the colossal planet. Additionally, the probe identified 2 previously unknown moons, Phoebe and Métis. Noteworthy is that Voyager 1 also transmitted intricate images of Jupiter's prominent Galilean moons, Io, Europa, Ganymede, and Callisto, alongside details of Amalthea. Like the pioneering work of the first spacecraft that preceded it, Voyager 1 brought to light the active nature of Jupiter's moons, portraying them as dynamic worlds in their own right. Voyager 1 also unearthed fascinating facts about these natural satellites, showcasing Io's numerous volcanoes and mottled yellow-brown-orange surface. These discoveries underscored that moons, similar to planets, can have active interiors, adding to the wealth of knowledge garnered by the Voyager spacecraft. Moreover, Voyager 1 captured and transmitted images of Europa, revealing a seemingly smooth surface marked by lines suggesting ice formations and hinting at the possibility of an underlying ocean. Following its encounters with Jupiter, Voyager 1 continued its mission, redirecting towards Saturn and providing close-up images of the ringed planet starting from 1980. Saturn, like Jupiter, presented unforeseen phenomena, including the discovery of the ethereal F-ring, a structure identified just a year earlier by NASA's Pioneer 11 probe. Voyager 1 also unveiled two newly discovered moons, Prometheus and Pandora, influencing the orbits of icy material within the F-ring. Additionally, the spacecraft encountered Atlas and the G-ring, capturing images of various other moons of Saturn. Among the celestial puzzles encountered by astronomers was Titan, the second-largest moon in the solar system after Jupiter's Ganymede. Despite close-up images revealing only an orange haze, sparking years of speculation about its composition, humanity had to wait until the mid-2000s for revelations. This insight came through images captured from beneath the haze by the European Space Agency's Huygens atmospheric probe. The encounter with Saturn marked the conclusion of Voyager 1's primary mission. However, the probe was far from retirement. Its focus shifted to tracking the 1,592-pound, 721-kilogram craft as it accelerated toward interstellar space. 2 decades before that pivotal occurrence, Voyager 1 immortalized a significant moment in the chronicles of space exploration. In February 1990, the spacecraft redirected its gaze towards Earth, capturing an enduring image of its home planet from an extraordinary distance of 3.7 billion miles, 6 billion kilometers. At this astronomical range, Earth looked like a minute speck illuminated by a slender beam of sunlight. On this remarkable day, Voyager 1 also snapped numerous additional photographs, taking a compelling family portrait of the solar system, including 5 other planets and the Sun. The most memorable image in this compilation, often known as the pale blue dot, stands as a poignant testament to Earth's role as a small sanctuary of life in the vastness of the universe. In August 2012, Voyager 1 accomplished another extraordinary milestone by journeying beyond the heliosphere, a broad envelope of charged particles radiating from the Sun. This revelation became widely known as interstellar space the following year, and was disseminated to the public by publishing a study in the journal Science. This groundbreaking discovery was made when Voyager 1's plasma wave instrument detected a potent solar eruption between April 9 and May 22. Electrons near Voyager 1 vibrated in response to this eruption, leading researchers to conclude that the spacecraft had entered a higher density region than just inside the heliosphere. At first glance, it might seem counterintuitive that electron density is greater in interstellar space than in the Sun's vicinity. However, researchers clarified that the electron density at the edge of the heliosphere is significantly lower than at Earth's surface. Examining Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This decision was not solely based on electron oscillations, but also on measurements of charged solar particles collected by the spacecraft on that significant day. Coincidentally, it was the day that renowned Apollo 11 astronaut Neil Armstrong passed away. On this pivotal date, Voyager 1 detected a remarkable 100,000-fold decrease in these solar particles, and a 9% increase in galactic cosmic ray flux originating from outside the solar system. Voyager 1 found itself at a staggering distance of 11.25 billion miles, 18.1